Required Practical on force and extension, also known as Hooke's Law.
Before we even think about touching the equipment, we've got to understand the physics behind it all.
What is Hooke's Law? It's all about figuring out the relationship between how much you pull on a spring and how much it stretches.
Extension. It's not the total length of the spring once you've stretched it. No, it's how much longer it's gotten from where it started. Get that wrong and all your calculations will be off. And here's the law itself. The key phrase to remember here is directly proportional. It just means that if you double the force, guess what? You double the extension. Triple the force, you triple the extension. But this rule only works up to a certain point. F equals K times E. That's force equals the spring constant K multiplied by the extension E. Check your units. It's got to be newtons for force and meters for extension. Don't get caught out using centimeters. So this letter K, what's it all about? Just think of it as the spring's stiffness score. The bigger the number, the tougher the spring is to stretch. So, the massive suspension spring in a car, that's got a huge K value. The tiny little spring inside your pen, a really, really small K. How do we actually do this experiment and collect the data we need? Just by knowing the equipment. You need a clamp stand to hold it all steady, the spring itself obviously, a ruler, a set of masses to add the force, and here's a pro tip, a little pointer, maybe just a paper clip to make your readings really spot on.
First, you measure the spring when it's just hanging there, its original length. Then you pop a mass on, let it settle, and measure the new length. The extension, that's just the new length minus the original. And then you just do it again and again. Add another mass, measure, calculate. The key is just being super careful and doing it the same way every time.
Now, this is where we turn that boring table of data into a graph, and that graph is going to tell us everything we need to know and let us see Hooke's law in action.
So your results table should end up looking a bit like this. But hang on, before you even pick up a pencil to plot anything, you have to convert the mass in grams into a force in newtons, and you have to make sure your extension is in meters. Do that first.
All right, graph time. Remember, force goes up the side on the y-axis. Extension goes along the bottom on the x-axis. And if you've done it all correctly and the physics is working, you should get this lovely straight line that goes right through the corner, right through the origin. That shows the linear relationship. And this is the big reveal. This is why we drew the graph in the first place. The gradient of that line, how steep it is, that is your spring constant, K. It's that simple. Just calculate the change in y divided by the change in x, you found the stiffness of your spring. You need to talk about what could have gone wrong and how you could make it better. This is where you really prove to the examiner you understand what's going on. So think of an elastic band. You can stretch it and it pings back, right? Springs are the same, but only up to a point. That point is called the elastic limit. If you pull it too far, you've gone beyond that limit. It's permanently stretched, damaged goods. It won't go back to its original shape, and your nice straight line graph will suddenly start to curve.
Okay, exam tip. Examiners almost always ask about errors, so have these ready. The number one classic is parallax error. That's when you're not looking at the ruler straight on, at eye level. Other easy mistakes? Measuring while the spring is still wobbling about, or maybe the ruler you used didn't start exactly at 0. But for every problem, there's a solution. To fix parallax error, get your eye level with the reading. Use a pointer to be more precise. And here it is, the golden rule of any school's science experiment. Repeat your readings. Do each measurement 2 or 3 times and take an average, a mean. It's the best way to make your results more reliable.
So let's just boil it all down to the absolute must-know facts from this practical. 1. Know the equation, F equals K times E. 2. The graph is a straight line through the origin until you hit the elastic limit. 3. The gradient of that line is the spring constant, K. 4. K is just a number that tells you how stiff the spring is. And 5. Stretch it too far, and you've permanently changed it. And to finish, let's just zoom out for a second. Don't for a second think this is just some weird experiment you only do in a classroom. Hooke's law is everywhere. It's in the suspension of a mountain bike. It's in the design of an earthquake-proof building. It's even in the clicky top of your pen. Once you know what to look for, you'll start seeing this bit of physics in action all around you.